Look at this small box. Let's look closely. What happens if you look closely again? Any small box will eventually be fragmented into a single atom. But look at these atoms. These are arranged with special rules by the atoms around them. Materials that are arranged regularly for special structure like these boxes are called solid. Solid consists of infinite number of basic blocks called unit grid. Now we are going to learn more about this special structure of solid. There are so many special structures that solid has. These structures were divided into 7 categories by Auguste Bravais, who is a French physicist. This classification system is called the Bravais lattice. There are 3 structures in the cube system. The most basic structure is the simple cubic lattice. Simple cubic lattice is a structure that one atom is placed at each vertex in a cube. Inside this structure, there is one atom in one unit. The second is the body-centered cubic lattice. Its structure is the addition of an atom to the center of a simple cubic lattice. The structure contains 2 atoms. One is placed at the center of a unit and the other consists of 1/80th of an atom. The third is the face-centered cubic lattice. In a simple cubic lattice, each of the 6 sides is partially charged with atoms. There are 1/80th of an atom at the vertex, each with a half of an atom on each of the 6 sides. So there are 4 atoms in total. So how many of these atoms are filling each of the units? We use a number which is called fill factor to express the ratio of the atom's total mass in the whole unit volume. It doesn't make sense easily just by looking at the formula. So why don't we calculate it ourselves? Let's start with the simplest structure we've ever seen, the simple cubic lattice. Let's define the length of one edge of the unit molecule is A, and the radius of the atom is R. Then the volume of the element is like this, and the volume of the atom is like this. Then the one edge of the unit is twice the length of the atomic radius. So you can get about 52% of the fill factor. Body-centered lattice, the volume of the atom is like this, and the diagonal of the unit body is equal to 4 times the atomic radius. So you can get about 68% of the fill factor. Finally, the face-centered cubic lattice, the volume of the atom is like this, and the diagonal of the unit body is 74% of the fill factor. There's one more structure which is the most dense. This is a hexagonal close-packed lattice, which consists of 2 atoms in total. All the atoms in each vertex make 1 atom, and the middle atoms. Look, can you see hexagonal structure? Ideally, these basic special structures should continue indefinitely, but the reality is a little different from the theory. This is called a defect. There are 3 kinds of defects. There is no atom in the place where it should be, and it is called Schottky defect. And when electron is not placed in which atoms ideally should be placed, and it is called epicenter defect. And finally, Frankel defect is that atoms are not in their original position. Let's go back to this unit grid and pile these atoms. More. The end.